with various resistors and connected in series, connected in parallel, connected to batteries. And so I want us to solve that problem or problems like that. And then I want to consider the RC circuit, which is in series, which is a circuit where you have a resistor connected in series to a capacitor and connected to a DC battery. So we talked about circuits with capacitors connected in series, capacitors connected in parallel. So we had that for capacitors connected in series, right? We had 1 over C equivalent equals 1 over C1 plus 1 over C2 plus 1 over C3 plus so on. We said that the voltage across the capacitor that is equivalent to the circuit containing capacitors connected in series is equal to the sum of the voltages across the individual capacitors. And the charge in the capacitor that's equivalent to the capacitors connected in series is the same as the charge in all the capacitors. They all have the same charge when capacitors are connected in series. And we said that if capacitors are connected in parallel, then the equivalent capacitance is given by the sum of the individual capacitances of those capacitors connected in parallel. We said that the voltage across the capacitor that's equivalent to the capacitors connected in parallel, is the same as the voltage across capacitor number 1, same as the voltage across capacitor number 2. So they all have the same voltage if they are connected in parallel. And the charges relate like this. So now we want to consider what happens when there are resistors connected in series. So, same idea, one resistor will be equivalent to the resistors connected in series, and so the equivalent resistance, or the resistance of the resistor that is equivalent to the resistors connected in series, is given by the sum of the resistances. The voltages relate like this. You add the voltages across the resistors connected in series to get the voltage